Welcome back. In this video, we're going to start exploring simple differential equations. In applying the integral, which is what this unit is all about, what we're going to be doing is we're going to be, first of all, solving these differentiable equations and doing a bunch of different stuff along with that. And then we're going to finally, in the last part of it, we're going to be finding areas, and then we're going to be rotating those areas around certain axes and finding volumes of solid or revolution. In these differential equations, what ends up happening is you're going to be given a derivative, and when you're given the derivative, you work backwards, you integrate it, and then you oftentimes find the arbitrary constant value, and you have to solve for y. We have different families of functions, that kind of stuff. There's a lot of different things that go along with this. This first video, where the equations are going to be pretty simple to work with, and then it just gets a little bit more complex. Nothing really new to teach you. We just got some examples to work with. So if we're given this derivative here, we integrate that 6x squared plus x minus 5. Set up that integral. Take the antiderivative. When I take that antiderivative, I'm going to get 2x cubed plus 1/2 x squared minus 5x plus constant, and that's going to be our original equation f of x. If I plug in this point then, if I put in x equals 0 and y equals 2, I find the constant to be 2. So then the original equation f of x is 2x cubed plus 1/2 x squared minus 5x plus 2. It can get a little bit more complex by making you do some use substitution on the integration. So I have this integral, this derivative this time is sine of 2x. I'm given this original point. So if I integrate the sine of 2x, u is going to have to be 2x. du is going to be 2 dx. So I'm going to multiply it by 1/2. So it's going to be 1/2 times the integral of the sine of u du. I take the antiderivative, and it's negative cosine, so it's negative 1/2 cosine of my 2x plus an arbitrary constant. If I then plug in this point, 1/2 1, I get negative 1/2 times the cosine of, it's going to be the cosine of pi plus c equals 1. This is negative 1. So then this all total is going to be 1/2 plus c equals 1. So c is 1/2. So then my equation f of x is going to be negative 1/2 cosine of 2x plus 1/2. Sometimes we're going to be given information about equations or about derivatives, that kind of stuff, and we're going to be given like areas, maybe a graph, or maybe something you have to work with on your calculator. You're going to be given an initial condition, like in this problem, I'm giving you g of 2 equals 7. That's going to be my starting point of every part of this. These areas, just so you remember, A, B, C, and D, these are 5. This is 5. This one is 4. I'm going to make it negative 4 because it's below the x-axis. This one is 5. And then this one is going to be 3. Now, everything is going to be starting at x equals 2. So when I ask you something like, what is g of 3? Remember, f is, I'm telling you f is a derivative of this. I'm telling you f is the derivative graph. So g of 3 is going to be my starting point, which is g of 2. That's where I know I'm starting. Plus, I'm going to add to that the whole amount of change between my starting point, which is 2, and then my ending point, which in this problem is going to be 3, of its derivative, f of x dx. This is going to be a concept that we're going to explore a little bit more in this later in this video, or not in this video, but in this unit as well. This represents the whole amount of change in the g value over the period of time between 2 and 3. In this particular problem, g of 2 is 7. I gave that to you. And then the integral between 2 and 3 would be this area, which is 3. So g of 3 is 10. It's the same idea with B and C here, except for things get kind of messed up in terms of order. So g of 0 is going to be g of 2, my starting point, plus the integral from 2 to 0 of f of x. What you're going to see is that those limits are backwards, so then we have to rewrite it. So g of 2 is still 7, but it's going to be 7 minus the integral from 0 to 2 of f of x dx. The integral from 0 to 2 of f of x dx is 5. So what I'm going to do is I'm going to take 7 minus 5, which is going to give me a value of 2. It's the same idea with negative 3. It's going to be g of 2. I'm going to write it, well, it's going to be plus the integral from 2 to negative 3 of f, which is going to be, in this particular case, 7 minus the integral from negative 3 to 2 of f, which is going to be 7, and it's going to be minus, and then from negative 3 to 2 is going to be 5, and then minus 4 is going to be 1, plus 5 is going to be 6. So 7 minus 6, which is 1. And then finally, in our last one, what I'm telling you is I'm defining another function, h of x, which is not related to g. It is related to f, but it's not related to g. Let me move this up a little bit, which is 3 times f of 2x plus 1. So when I integrate this, and I want to know what the value of this integral is, what I'm going to do is I'm going to go ahead and write it as negative 2 to 1, and I'm going to plug this in for h. So 3 times f of 2x plus 1 dx. We don't know what that function of f is. I've got to use some u substitution because of this 2x plus 1. So u is 2x plus 1. du is 2 dx. So I'm going to have to multiply it by 1/2. I can also pull that 3 out front. So it's going to be 3/2 times the integral. Now I have to change my limits. So if I plug in negative 2 there, I'm going to get negative 3. If I plug in 1 there, I get positive 3. And that's going to be f of u du. What ends up happening then is this part right here, this integral from negative 3 to 3 of f, is going to be all these areas added together. So that's 9. So it's going to be 3/2 times 9, which is 27 over 2. And then finally, sometimes we're giving you things like this that you can't integrate necessarily. So this is my derivative, is square root of x squared plus 1. I'm telling you the starting point f of 2 is 1, and I want you to find f of 0. Well, f of 0 is going to be my starting point, which is f of 2. We know to be 1 in a minute. Plus the integral from the starting point, which is 2, to the ending point, which is 0, of the square root of x squared plus 1 dx. Now in this problem, you can't evaluate the square root of x squared plus 1 dx by hand. You don't know how to do this. I have not taught you this. So what you have to do is you have to deal with it on your calculator. And so if I deal with it on my calculator, I'm going to just put that in just the way I have it, like this. So the integral, I replaced f of 2 with 1 plus this integral from 2 to 0. Your calculator is very smart, so we'll switch this sign for you. You don't have to do anything with it. And that's going to be negative 1.957 or 958 to 3 decimal places. All right. Hope you're understanding this, and we'll clarify in class for you the best we possibly can. See you soon.